This video is going to cover section 4.4, which is graphing inequalities and systems of inequalities. An inequality is just something that's not equal. It can be greater than, less than, greater than, or equal to. You graph a linear inequality the same way you would graph a line, an equation. There's just a couple extra steps. So the first thing we want to do is rewrite it as y equals a number. So we're going to get this 2x to the other side. Then divide everything by 3. So 3y divided by 3 is y. 6 divided by 3 is 2. And negative 2 divided by 3 is negative 2/3. We have that there. Now we're going to graph it. So start by graphing it just like any other line. This is your y-intercept. And then the slope of this one is negative 2/3. So we would go down 2 over 3, down 2 over 3. Those dots would represent the line. If you have a less than symbol, like A and C, if you have a A or B, less than or greater than symbol, you're going to draw the line with dots or a dashed line like this. If it can equal, you draw it with a solid line. Then your less than ones, you shade under the line because that's where y is getting lower. And your greater than ones, you shade above the line. So this equation is less than. That's why I did the dots. And now I'm going to shade underneath. I don't know what I did there. So then I shade everything underneath the line. And anything in that red shaded area would be the solution. You write the equations the same way. So if we were just looking at this line right here, our y-intercept would be 0. And then our slope would be up 1 over 1. So our slope is 1. So if it was just a line with no shading, we'd have y equals x. Now let's look at the original line. That is a solid line. So we know it's either less than or equal to or greater than or equal to. And we're shaded underneath the line, so that means it's less than or equal to. So our equation would just be y equals less than, or y is less than or equal to x. Let's do the same thing. The equation of this line, it's a vertical line, so it's x equals. And the x value it goes through is negative 2. Looking at the original line, it's dashed, so we know it's either less than or greater than. And we're shaded, because it's up and down, there isn't an over or under, but we're shaded on the side where x gets bigger, so technically it's over. So it would be x is greater than negative 2. That's how you write those. Your graphing calculator will also graph these for you. You're going to enter the equation that you get in your y equals menu, and then we'll choose. So if I were doing this first one, y equals 1, pull up my graphing calculator. In the y equals, that top left button, I'm going to type 1. Maybe. 1. There we go. Now I'm going to arrow over so that the highlighter, the equals is highlighted, or it has a box around that y part, depending on what your calculator looks like, and hit enter. Then I'm going to change the line. If it's less than, I want to choose the one where under the line is shaded. And if it's greater than, I want to choose the line where the over side. So this would be less than, this would be greater than. Some calculators will also give you a second choice of having a dashed or a dotted or dashed line. Other ones, depending on the addition or how new it is, you can only do this. So when you draw it, you'll have to show me. So then you hit OK. And we hit graph. And it draws the line at y equals 1 and shades underneath it. And because this is less than or equal to, I can keep it as a solid line. Let's try the next one. We want it to say y equals, so I subtract the y from both sides. So in y1, I want to type 3 minus x, 3 minus x, 3 minus x. It's still less than, so now I'm going to hit graph. There would be our graph. If I did it by hand, I would go up to the 3, down 1 over 1, down 1 over 1. Because this is less than but not equal to, it's a dashed line, and we shade underneath. If you were to turn this in on a test, you can take a picture of your graphing calculator and send that. Just make sure you also note that that line should be dashed. Otherwise, you won't get full credit. Okay, I would pause the video to try this one and then check and see how you did. So I'm going to move the x by adding it. 2y is greater than or equal to 2 plus x. I'm going to divide everything by 2. So we get y is greater than or equal to 1 plus 1/2 x. In my y equals 1 plus 1/2 x. We want to change this to the greater than. Hit graph. So that would be a picture. If I were to do it by hand, I'd go to 1, up 1 over 2, up 1 over 2. It's a solid line, and I shade above. So looking at my graph, something happened. There we go. I don't know why it did it that way the first time, but now I graphed again. So you can also use it to double check yourself and say, hey, it should be shaded above. Why didn't I? When you're graphing systems, you do the same thing. You just graph both equations, and the answer is where both colors are. So if I were to graph this first one, x is greater than -1. So I'm going to put my dashed line at -1 because that's the line. Then I would shade above, so where the x is greater. So the purple is the first one. Let's do the second one let's do it in blue. Why not? Let's do it in blue. How about green? I'm trying to make them look a little different. There we go. So I'm going to subtract x from both sides. So I get y is less than or equal to 1 minus x. My y-intercept would be 1. My slope is -1, so I go down 1 over 1, down 1 over 1. There's the line. It can be solid. And then I shade underneath. So now we have those two colors. The solution is this area right in here that has both colors. So you can do it as a third. You can leave it like that and put a smiley face. Just anything in there, even just leaving it so I can tell that's two different colors on the calculator. I mean on my graph. Let's do the same thing here. Make them both say y equals. Let me try this again. Having a moment. There we go. So I'm going to subtract the x. Divide by 2. Y is less than or equal to -1 minus 1/2 x. So -1, down 1 over 2, down 1 over 2. Can't equal, so it's a dashed line. Less than tells us underneath. Then if I do this other one, I'm going to subtract 2x from both sides. 2 minus 2x, so I go up to 2. Down 2 over 1, down 2 over 1. This one can be equal, so it's a solid line. And we're greater than, so I shade above. And the answer would be down in this little section right here that has the two colors. If I wanted to do that on my calculator to check, or just that's how I wanted to do it, I'm going to put the purple one in y1. So -1 minus 1/2 x. And this should be less than. Then, oops, this one's going to be 2 minus 2x, and it should be greater than. So I pick that symbol. Then if I hit graph, it should match. And there we go. Again, remember, if I took this picture, I would want to make sure to say that that blue line should be dashed. All right, let's try a word problem. Business manufactures MP3 players and digital video players. Every video player has an MP3 in it, so they have to make at least as many MP3 players as digital players. Shadow! My dog's being loud. In addition, the total number of MP3 players and digital players cannot exceed 50 because of limited resources. Shade the region. So let's say X is our MP3 players, Y is our digital video players. There has to be at least as many MP3 players as digital video players. So X has to be the same or bigger than Y because you have MP3 players in the video. If we flip that over so it's written like Y equals, Y is less than or equal to X would be our equation. So our y-intercept would be 0, up 1 over 1, up 1 over 1. So this line right here, and then we shade underneath because we're less than or equal to. Now let's do the second one. MP3 players and digital video players cannot exceed 50. So if we add them up, they have to be less than or equal to 50. So I'm going to subtract X from both sides, and we get 50 minus X. Now to graph this, I'm going to go up by, let's do every 2 is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And as long as I do the same scale on the bottom, I don't have to change this red line. So, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Now, for example, the red line, if I went up 10 over 10, I'd have a dot there. Up 10 over 10. So as long as the scales are the same, I don't have to change that line. Now, for this line, we're going to start at 50, and we're going to go down 1 over 1, which means I can go down 10 over 10, down 5 over 5. It doesn't matter as long as they're the same on the top and the bottom. So this line would be the one that represents the second equation, and it's also less than, so we shade underneath. And then our directions say, shade the region that shows the numbers that are produced. So the only part, anything in this little greenish triangle can be produced. We can make 25 MP3 players and 10 video players, and we meet that criteria. That's what that means. So now let's look at this last problem. The shaded region shows recommended weights for heights. So at some point, someone decided this is what a healthy weight is inside that shaded area. So what does this indicate about a person who is 68 inches tall and weighs 150 pounds? So 68 inches is here. 150 pounds is here. They intersect in that area. So that means they're considered to have a healthy weight because it's within that area. Now, the other question, what do ordered pairs to the left of the shaded region indicate? So this is the left. So our weights are smaller. So that means, according to this chart, the people that fall in that category would be underweight. That's just how to read a system the way it's written. So that is the rest of 4-4. Let me know if you have any questions.